Hi, sixth graders. So we are starting chapter 9, which is on probability, and this is lesson 1. So over this chapter, the essential question that we are going to be answering is how can you predict the outcome of future events? More specifically, in this lesson, we will be learning how to find the probability of an event, so that would be a specific event, and then to find the probability of the complement of an event. So a complement of an event, if you have two things that are likely to occur, that would be if you were to flip a coin, and the two events that are to happen are heads or tails. Heads and tails, the probability of those two events happening are complements of each other. And then our vocabulary for this lesson is the probability, which is the likelihood of an event happening. Outcome are the different things that can happen from that event. So you are finding the probability of an outcome occurring. And then a simple event is when the probability of the two events that are happening are equally likely to occur. So, for example, like I said before, if you were finding the outcome of flipping a coin, you have heads and tails, and the likelihood of each of those happening are equal. It isn't more likely that it's going to be heads or it's going to be tails. You never know, and it's just you're flipping a coin. That's the probability. So then random for the vocabulary is that you don't know what's going to happen. Flipping a coin is random. You never know if it's going to be heads or if it's going to be tails. Now, you could predict and be correct because that's just part of probability. You could find out, like, oh, I think this is going to happen, but it is random. And flipping a coin is random, which is just one example of finding probability. And then again, complementary events, which I said before, that's when two events complement each other, and always if you are adding complementary events together, the probability is always 1. So that means that all of your complementary events added together equal a probability of 1, meaning those are all of the events that are possible to happen. So if you were to roll a dice, you would have the complementary events would be the event of rolling a 1, then rolling a 2, a 3, 4, 5, and 6. Those all 6 possibilities are complementary to each other. Now, specifically, our key concept is probability. That's what this chapter is about. And we will dive deeper into different possibilities of probability and the different lessons of it. But in words, the definition, the probability of an event is a ratio that compares the number of favorable outcomes to the number of possible outcomes. And then in symbol, what that means as the ratio, how they described it as a ratio, this is how they show it right here. So we have the probability of an event, and it's always going to be P, and then your event is going to be in parentheses. So, for example, the probability of rolling a 6 when you roll a die. Then you have a ratio of the number of favorable outcomes, which your number of favorable outcomes is always what the event is. So the probability of that event happening. The number of favorable outcomes. Rolling a 6 is just one event. You only have one side of the die that says 6. So your number of favorable outcomes would be 1. And the number of possible outcomes is, it's a 6-sided die. So you have 1, 2, 3, 4, 5, and 6. So there are 6 total outcomes. So the probability of rolling a 6 would be 1/6. And then we're going to also go back to something that we have learned previously in turning these fractions into percents and also into decimals. So now, as I said earlier, There are 6 equally likely outcomes if a number cube with sides labeled 1 through 6 is rolled. So that means that it's a simple event, as we said before with our vocabulary, because there are equally likely outcomes. So when we are looking at a 6-sided die, let's say, for example, the probability of rolling a 5, which then we know that there's only one side that has a 5, so it would be 1 because that's the number of favorable outcomes that we have in our ratio, and the bottom, which is the total, is 6. So the probability of rolling a 5 is a 1/6 ratio, or I think it's about like 17%. So the likelihood is 17%. Now, if you were to do that for every single one of them, you would get 1/6 or 17%, which that's what they mean when they say it's equally likely outcomes. So now example 2. Find the probability of rolling a 2, 3, or 4 on the number cube. So the word or in this sentence indicates that the number of favorable outcomes, so the numerator in our ratio, needs to include the numbers 2, 3, and 4. So we are finding the probability of a 2, 3, or a 4 being rolled. Now, when it's all of the numbers in the cube, there's only 6. It's a 6-sided die, correct? So we have the number of favorable outcomes in our numerator is a 2, 3, 4. So that's 3. There's 3 different things that could happen. So it would be 3 in our numerator, and then there's 6 sides, so it's a 6-sided die. Now you need to simplify. For example, in this one we can divide both the numerator and the denominator by 3, getting 1/2. So there is a 50% chance of you rolling a die and it becoming a 2, 3, or a 4. So now, as we talked earlier, we have 1/2, which is also 50%, or it is a 0.5 at 0.5 as a decimal. So now example 3. Find the probability of not rolling a 6. So in example 1, which is what we talked about when we were rolling a 6 on a 6-sided die, we found out that it was a ratio of 1/6, 1 out of 6. So we know that the probability of not rolling a 6 and the probability of rolling a 6 are complementary. Those are the two things that could happen. You either roll a 6 or you don't. Those are the two things that are happening. So the sum of these probabilities is 1, since they are complementary. So you have the probability of rolling a 6 and the probability of not rolling a 6. And I just said, when you have complementary events, it's always going to equal 1. Now, we can insert the probability of rolling a 6 because we already know what that is. So we have 1/6 plus the probability of not rolling a 6 equals 1. Now, personally, I'm going to write 1 as 6/6. Now, that's because I know that 6/6, or a number above itself, it always equals 1. And I want it to be 6/6 because the denominator over here is 6. So then I can look at it a little bit differently to be able to figure out this part of it. So we have 1/6 plus probability of not a 6 equals 6/6. Now, this is just like how we were working with equations and variables. We don't know this value, so we want to get it by itself. So we will subtract 1/6 from both sides, getting the probability of not a 6 equals 5/6. So now looking at those two, you know right away that the probability of not rolling a 6 is a lot higher than rolling a 6, because the probability of not rolling a 6, 5 over 6, is about 83%, or 0.83 in a decimal. So now, last problem. Mr. Harada surveyed his class and discovered that 30% of his students have blue eyes. Identify the complement of this event, then find its probability. So now we know that the complement of this event, that means that there are two different things that could happen. So we have the probability of blue eyes plus the probability of not having blue eyes and since these are complementary events, we know that these two are going to equal 1, or in this case, since we have a percent, it's going to equal 100%. Because 100% of the time, either someone's going to have blue eyes or someone's not going to have blue eyes. Those are the two options. So we know that the probability of blue eyes is 30% plus the probability of not blue eyes equals 100%. And then we would subtract 30% from both sides. So the probability of not having blue eyes equals 70%. And if we were to write that as a fraction, it would be 7 over 10, or 0.7. Now, we will work in class on some warm-up problems, and then we'll work on some worksheets. So if we have any questions at all, please bring them to class. Make sure we're taking notes, and we turn in our homework tomorrow morning. Have a great night.